So there are two ways to answer this question. The first way that you could go about it is you could say you have a variable expression times another variable expression, and so that would tell you that you would need to use the product rule. There is also going to be an easier way, and that's going to be to use trig identities, which we'll talk about at the end of this video. So if you wanted to use the product rule, you would have your first function as sine of 2x, and then your second function would of course be the cosine of 2x. Now, first function's derivative is going to be cosine of 2x times 2. And again, we need to say times 2 because we have a function's argument that is something besides x. So because we have an argument besides x, we have to use the chain rule and multiply by the derivative of the inner function. And then for our second function's derivative, cosine is negative sine of 2x. Same idea here, because the argument is something besides just x, we have to multiply that by 2. So plugging into the product rule, we would have that h prime of x is equal to our second, so cosine of 2x times the derivative of the first, cosine of 2x times 2. Plus, and then we would take our second times the derivative of the first. So that would give us negative, well, let's write it out as it is. So the sine 2x, and then times the negative sine of 2x times 2. So this then is going to give us 2 cosine squared of 2x, and then minus 2 sine squared of 2x. Now, if you look back in the back of the book, what you will see is that they have a different answer than that. They have 2 cosine of 4x. And the way that they get that is using our double angle formula. So what you'll notice with this question is that if you had left your answer in this form, I would be perfectly fine with that, but there is this double angle idea that is coming up in this question. And so an easier way of going about this would be to go at the very beginning of the question and use our double angle formula for sine of 2 theta. So the other way that you could do this would be using trig identities. So if I use my trig identity, I have a trig identity that says sine of 2 theta is equal to 2 sine of theta cosine of theta. Now, if you look at the original problem and the sine theta, cosine theta, our original problem takes on this structure because our original problem was sine of 2x, cosine of 2x. So if we line this up, what we want to do is we want to let theta be equal to 2x. So if we let theta be equal to 2x, this identity will become sine of 2 times our theta, which is 2x. So we will get sine of 4x is equal to 2 times sine of 2x cosine of 2x. Now, in this particular question, we're only interested in differentiating sine 2x cosine 2x. So because this identity is true, what we could do is we could solve for the function of interest. We could divide both sides by 2, and we would get that sine of 2x cosine of 2x is equal to, by a trig identity, is equal to sine of 4x all over 2. And the key thing is whether we differentiate this function or differentiate this function, because of the trig identity, we are taking the derivative of the same function. So now what I would do is I would take the derivative of the sine of 4x over 2. The 2 is a constant coefficient, so it's going to tag along. The sine of 4x becomes cosine of 4x, and then we multiply that by the derivative of the inner function because our argument was something besides x, and that will be times 4. So upon reducing this, you will get 2 cosine of 4x is equal to the derivative of sine of 2x cosine of 2x. And so that's another way that you could go about taking this derivative, is initially starting with the trig identity.